So I mentioned that gas exchange only takes place in the alveoli of the lungs. So that is where your respiratory membrane is. The rest of the lungs would be the conducting zone of the lungs. So it's just conducting the air down into it. Gas exchange is a passive process, and so it involves diffusion. So the gases, carbon dioxide and oxygen, diffuse with their concentration gradients. So from a higher concentration to a lower concentration. So gas exchange is passive diffusion. So gases are dissolved in water, and so they move from a higher concentration to a lower concentration. So that means that we don't have to use energy to pump the gases. We don't have to use ATP. So our system is designed so that there is always a difference in the pressures, difference in the concentration. So the concentration of gases is called the partial pressure. So you just need to know that our atmosphere is composed of more than one type of gas. And so like oxygen is like 21% in our atmosphere, and nitrogen is much higher. And so that concentration is its partial pressure. So the differences in the partial pressures is designated as a delta P. So this is the difference in the partial pressure. So we need that value to stay a positive value so that the gases will always diffuse in the correct direction. So if we look at this gas exchange, here we can see that in the atmosphere, our partial pressure of oxygen is about 159 millimeters of mercury. You don't have to memorize these values. That is just about 21% of the atmosphere. Notice that carbon dioxide is at a much lower concentration. So when we're looking at the movement of the gases, when blood is coming in, let's say my partial pressure of oxygen, let's use a different. My partial pressure of oxygen is 40 millimeters of mercury. So that's blood coming into my lungs. My partial pressure in the air in my alveoli is 105 millimeters of mercury. So this is the alveoli, and this is in the blood entering the alveoli. So it's designed so that when we have the blood coming in, this difference in pressure between 105 minus, so my difference in pressure would equal 105 minus 40, which would be what? 100 minus 40 is 60. So that'd be like 55. No, 65. So that would be difference in partial pressure is 65 millimeters of mercury. So that is going to cause oxygen to diffuse in, and then vice versa. If we look at carbon dioxide is coming in at 45, in the air it's at 40, and so carbon dioxide is going to diffuse out. So that difference in P, which is the difference in the partial pressures, as long as it's positive, then we're going to have that gas to diffuse. Now, when you go up onto the top of a mountain, or if you go up to a higher altitude, there is a lower concentration of oxygen. And so that can sometimes make you very sick. And it can even actually cause you to die. And so that's why when people are, going up to Mount Everest, they take oxygen with them. They also acclimate themselves so that they go from one level and they wait maybe a week, and then they go up a little bit higher, wait a week, go up a little bit higher, and they're acclimating their body so that they are adjusted to that lower level of oxygen. So this difference in partial pressure depends on where you are on the planet. And then, so that is the movement of gases, the diffusion of the gases.